We're going to try some new things here today. Um, Trying to put the comments to the side for everyone who wants to see it. Um, so today we are talking about um, React rendering. So it's an advanced concept of React. Basically, these are things that I get asked. Well, I don't get asked quite a bit. I actually ask people quite a bit about learning about this stuff, and so these are definitely things that I think are this is something I think is good to know for anyone who wants to be a front end developer and that type of stuff. Um, like I said, this is a question I ask a lot and doesn't really get answered very well or at all. So I think it'd be good to learn if you're, even if you're, you know, especially if you're a front end dev, especially if you're front end dev working in React, it's a good thing to know how it works in general. And hopefully we go into a little bit more detail than just the general today. I will be showing some code. It's not really code that's specific to React rendering, but it is going to show what React rendering, the basis of it, and that type of stuff. But we'll start with the discussion first, and then we'll move to code. So here, let's kind of, there we go, like that. All right. So basically, yeah, React rendering it's the concept of how React determines if in general, how React determines if a component actually gets redrawn on the screen, how if the DOM gets updated, and that's maybe that's the best way of saying it. If the DOM that's contained within the component actually gets updated, and so knowing how this works, knowing how this interaction plays out, can make you a much better React developer. There's also some pieces of this that tie into JavaScript in general. So it's very important. It's helpful. It's helpful to know this type of stuff, basically. So let's sort of start at the here. Let's start at the. I'm going to go ahead and hide the chat overlay because I'm going to actually do some screen shares pretty early on. One of the first things that I talked about was object.is. Let me see if I can actually find where I saved that at. Yeah, it's going to be over here. So I made mention of object.is and the object.is method in JavaScript. And the object.is method in general, what it does is it does a comparison between two items. I'll go ahead and just showcase real quick here. Let me do this. There we go. All right. So I'm going to go ahead and showcase this real quick here. We can start with that. Yeah, share screen. Oh no, I'm not going to be able to do screen shares. Oh, I just forgot about that. That's right. I have a new Mac, so now I'm going to have to let Google Chrome. Let's see here. Screen and audio recording here. Okay, everyone. I'm going to have to quit and reopen because I do want to be able to do screen shares on this. I am sorry, but yeah, I completely forgot about the fact that I'm going to have to actually be able to screen share, be able to actually do that with Google Chrome and let Google Chrome have access to that. I will be back up in just a matter of probably a minute. So here we go. Oh, wow. Okay, that's interesting. It kept us live. So I guess I just came back in. I thought I was have to restart the stream. That's pretty awesome. Very, very good. All right. So let's get this back to where we were. All right. So there we are. So yes, we were talking about object.is. I'm going to go ahead and bring that up. We'll take a real quick. For those of you um, who don't know or whatever, probably one of the best JavaScript resources out there is the MDN site, Mozilla Developer Network. It's definitely the one that I use quite regularly. It's pretty up to date, and it's because if you don't remember from earlier conversations, um, Mozilla and all of them, they actually were one of the earlier companies involved in creating JavaScript. So of course, they're going to have a very good library on it because they kind of were the start of the whole thing. So here is object.is. Now, object.is is basically a method that compares two items. So if is an item equal to another item. And so as you can see, this is a pretty basic one. Is the string one equal to number one? Of course it's not, it's false. So that shows that this doesn't do coercion or anything to get two values, because a lot of times if you use the single equals in JavaScript, if you say single equals the string one to the number one, it'll actually coerce the values to where they are equal and return true. So this is somewhat like the triple equals. But as you can see, there are things about triple equals that is not true as well. And object.is is what gets used as part of React rendering. So that's why I brought up object.is, and I said I would talk about it. So basically, yeah, object.is basically does a comparison. There's a whole description about how object.is works. If you want to see it, I'd recommend reading into it if you want to know more about it. I'm not going to go through it here. Kind of to me, if the resource is there, I don't see the purpose. So you guys can take a look at that. Anyways, how does object.is play into React rendering? Basically, it plays into React rendering in the way of how it determines if a component needs to run a render cycle. So how does it figure out if it needs to run a render cycle? Well, basically what happens is each time, okay, let's kind of start. This is almost what I do in interviews. So in interviews, when I'm interviewing people, especially when I'm interviewing more senior level developers, I ask them, more advanced questions, because they should, as a senior level developer, they should know some of these things. This is usually where this goes. So this kind of goes down the path of this kind of a question. So if you got to think about it, if you have a React component that is memoed meaning that it is actually it uses the React memo function to basically keep it to where it won't re-render unless the properties change. In React, if you have a parent component and that parent component does a render, even if the child component has no properties that change at all, the fact the parent component renders will cause the child component to render. It's just the way React works. Unless that child component is memoed. If that child component is memoed, then if the parent component renders, the only reason the child component will render is if a property changes. That's where this talk is coming into. That's where we are discussing about this. So that's why object.is is important. Object.is is important because that's how React determines if it needs to actually render. Now, there's a side effect of the way object.is works. Now, if you're comparing, of course, in React, you wouldn't one time pass a number and one time pass a string. So you're not going to worry about that. So what I like to call the primitive types, which is number, string, Boolean. There's one more. Wait a minute. Number, string, Boolean, whatever. Yeah, it doesn't matter. Basically, the primitive types, those will always be a one-for-one comparison. They'll be easy comparison. Those, if they are the same value, object.is will return true. As it is it the same? So object.is will return true in that they are equal. However, when you get into more complex variable types, property types, object.is does not work that way. A good example: if you end up having two objects that their values don't change. So if you have an object that's passed into a property and it doesn't change, nothing about that object changes, and that same property, it's that same object value gets passed into the property, it will fail the object.is comparison. Why is that? Because of the way object.is works. Object.is works by comparing, in the case of an object, by comparing the reference, the actual object reference. It doesn't do a deep comparison. It doesn't do a property to property, and dig down through however many levels of properties it does to compare the actual object. What it compares is the actual reference object. So what happens is, if you have a parent component with a child component that's memoed, and you've got an object in there that that doesn't change, but is not itself memoed, then what will happen is it will technically, as the parent component renders, technically that object property, that object that's going to be passed in as a property, will be recreated. And when it's recreated, the reference number between the two objects will be different, even though the values are exactly the same. Even though nothing has changed and the values are the same, the actual object references will be different. And so when you pass that object, even though it hasn't changed, into a property for a component, for a child component that is memoed, it will go ahead and fail the object.is comparison and cause a re-render. This is very important to know, because if you're going to memo a component, it's a more intensive process. It takes time to memo a component, and you're only trying to do that because you want to decrease the number of actual renders that are happening. So usually what you would try to do, if you're going, especially if you're going to memo a component, is you try to break down the properties into only the necessary ones that are needed, and you try to break them down into properties that are, like I said, primitive type, string, number, Boolean, those kind of things. Things that can succeed on the object.is comparison each time around, as long as their actual value doesn't change. But see, they're compared by value. Like I said, objects are compared by reference, and so that's the difference there. And so basically you try to do that. However, there's just times where sometimes it would be too complex. Maybe the object you're passing into this child component is far too complex to break out into its individual properties. If you can break out a couple properties from the object and pass the individual properties in, that's probably a better way to go if it's not going to be too complex. But if you're breaking out, 15, 20 properties, that could get quite complex. And sometimes you may not even know the exact properties within that object per se. And so it may not be something that's possible, or it may not be something that's the best way of doing things. So sometimes you have to pass that object. And so that's where the object.is comparison will always fail. And the one thing you need to do then is, in your parent component that has this object property, you need to memo using the use memo hook. You need to, although this is going to change in React 18, FYI, because at least from what I've understood so far, React 18 is going to change the way memos work and going to change all the stuff. So going forward, this may not apply as much anymore. But let's be honest, we're not all going to be jumping over to React 18 right away. So there's a pretty good chance that this is going to be this is still something we're going to have to think about for at least the foreseeable future. And who knows how things are going to go with React 18 and how all that's going to go anyways. But let's not get off track here. So basically, you need to use the use memo hook to actually memo the object itself and make sure that if nothing changes in the particular dependency items, the ones that are specific for that object, then it just returns the reference of the previous object. Now, I did say that I was going to do some code showing. This is where the code's going to come in, because I'm going to showcase my own use memo. So I have written a use deep memo is what I used, because once again, use memo has the same problems as JavaScript in general does. The basic use memo, what it does is it does an object.is comparison on the dependencies. So if you pass an object into your use memo, or more specifically, if you pass an array, because I really don't see why you would pass an entire object into use memo, but I have had the need before to pass in an array of items and to see if that array changes. Now, I'm not sure how many know this, and this would only be something you would know if you had done it enough times that you've had to fight with it before. First of all, arrays are objects in JavaScript, but they're a special type of object. Now, when you put an array as a dependency inside of something like use memo or use effect or something like that, the way it works is it does not fire. Hang on, let's see here. I'm going to go ahead and put this in the overlay so people can see what's being said. Of course not. There it goes. All right. And so let's see here. We got another Brandon. Let's see here. I find that when I know this much about something, it's because I spent a long time trying to figure out a problem that nobody seemed to explain well. This came up in a daily grind and caused a sticking point. Yes, it did. This has come up plenty of times before. I've had to fight with this numerous times in my current project and in in my current project especially. I've been on this project for 3.5 years now, so it's definitely something that I've had to fight with, and that's why I wrote my own stuff to do this, because it's just kind of a pain. It's kind of a pain to deal with. Here's the issue I'm bringing up. If you're using an array as a dependency, and sometimes you need to, what I thought when the first time I did it is, an array is an object, so every time it renders, it's going to change. That's not true. That is not true. I would think, since it's an object, each time it's recreated, it actually would just fire, and so you're going to have the use memo firing over and over and over and over again. No, not true, actually. If you go into an array and you change the internals of an array, but you don't change the actual count, the actual number of values that are held by the array doesn't fire anything. I've seen this before. I've seen it to where I've gone in and I've made a change to an array, but I added and removed the same amount of items, and so the item count, the length of the array, stayed the same. And since the length of the array stayed the same, the use memo or also use effect did not fire. Neither of them would fire when that happened. So so that's where this whole thing kind of came from, was that. Here, I'm going to go ahead and I'm going to pull back the overlay now, because I'm going to do a screen share here, and I want to make sure everyone can see this. So hopefully this will help with everyone seeing. I just want to make sure that I've got the right thing here. Yes. So what I'm going to show now is how I wrote my own use deep memo. This uses a library called, let's see here. Oh, it's not there. It's over here. Fast deep equals. It's an NPM library. You can find it on NPM fast-deep-equals. So it's very small. If you go through the code, which before I usually use something like this, I almost always do, you'll see it's about 67, 68 lines of code. And some of those are switch type situations where if you're using, he basically built like a templating kind of thing, where if you're using React, he's got a couple more extra lines of code that get put in there to stop infinite recursion on certain React objects. And then he's got stuff that's specific for like ES6 maps and different types of ES6 objects as well. So it's pretty interesting. You got to go through the code if you like it. I learned a lot from reading through his code. I learned a lot about performance, about JavaScript performance. That's something I would actually, maybe that's not a bad idea for another conversation. Anyways, let's move on. I don't want to talk for too long, but let's go to Bsoft Common. All right, here we are. So, yep. All right, it says we're showing. All right, so this is our use deep memo. Now, use deep memo, if you look, if you see this, looks very similar to a normal use deep memo, and that's because I basically took the same structure here for use deep memo and use the exact same thing. You got the factory, which is just an empty function that then passes back a type. We're using TypeScript here, so we've got this is a generic, and this is how we can have use deep memo tell us when we use it what type it's actually using. You know what type that's being passed back, and then the dependency list. This is actually React. If you look, this is a React dependency list. So this is actually, like I said, this takes exactly how use memo works from React, but it does it itself. Basically, we didn't want to do that. Basically, we create a list, or we create an array. So the array is the dependency list array, and then it's actually the type. That's the array we're looking at. That's why down here you'll see that it returns memo current 1, because that's the type itself. So that's just setting up the ref. Now this is the ref. This is the holder. This is what will hold our actual type. So basically, that's how use memo works, to where it returns the exact, it doesn't cause a re-render when you use memo, because it returns the exact same reference. So the object actually itself never changes. The object never changes, and it uses the exact same reference, and that's how use memo works under the hood. In this case, though, what we're doing here is we've got isChange, which is our way of trying to determine if the dependencies have changed. So as you can see, current 0 is the dependency list here. So 0 is the dependency list. So we're passing the dependency list, and we're passing the current dependencies in here. So this gets called each time a component is rendered. It passes the new dependencies to the use deep memo. That gets passed in here to arrays are different. This is where deep equals comes in and plays a part. So what we're doing is we're literally looping through the old and the new array, and we're trying to compare each individual item of there. If at any time any of these are not equal, we return true to arrays are different. True then causes isChange to happen. So if isChanged is true, then we go ahead and we rerun the memo factory function. If not, if nothing has changed, if either, as you see here, this is saying if the memo is currently a length of 0, meaning that this is the first time. So the first time, it doesn't matter if it's changed or not. We don't have anything memoed. So the first time we have to run the memo regardless. But each time after that, each run after that, isChange determines whether or not we actually rerun the factory function and create a new object. I mean, really, this is very simple. As you can see, it's a total of 18. Well, depending on how you look at it. If you look at it from here to here, what are you looking at? 10, 12 lines of code, and I got some good spacing in here. So it's not a lot of code, but the concept is there. Also, I clone deep, by the way. I wrote my own clone deep. So yeah, I clone the dependencies. Now, I'm not sure if anyone knows why I would clone the dependencies, but I clone the dependencies because if you assign dependencies in JavaScript without actually cloning it or creating a new object of it, then what can end up happening many times is when you make a change to that somewhere else, you've got the reference. You don't have the value of that object, but you have a reference, especially if it's an object, you have a reference to that object. And when something else changes that same object, it will change up here, and that's not what you want. What you want is you want a snapshot in time of those dependencies, and if they happen to change somewhere in the process, they shouldn't, but if they do, we would not want to have that affect those and then not cause a new memo to be called if that's what should happen. So that's why the clone there. That's why we clone deep the dependencies, so we make sure that we're comparing value to value, not having the whole reference crossover thing happen when you assign. If you look, there's a lot of JavaScript examples where if you take an object and you simply just assign it to another object, and then you make a change to the previous object, the assigned object also has that same value now, because what you've done is you've basically just assigned a reference there, and you haven't done anything to actually assign to actually change the actual value itself of the other object. Hang on a second here. I've got dogs that are now barking. Like I said, live streams. Like I said, that's the great thing about live streams. Sometimes you can't help what your misbehaving dog is doing. Anyways, so back to where we were. So yeah, that's why the whole clone deep is happening here, to make sure that we're doing that when we do the comparisons up here, because I did actually have that happen. I actually made the mistake of not doing this the first time I tried it, and then I realized my memo wasn't firing, and I'm wondering why isn't my memo firing? My memo wasn't firing because when I was making a change to one of the dependencies, when the change happened to the dependency, it was already making it here, and then they were doing the objects came out being equal. So you ended up not having the memo fire ever. It fired the first time and never fired again. So yes, the clone deep was important. And then, like I said, the last thing is we just return the object. So we know how big this array is. We know item 0 is the dependency list, and item 1. Oh my dear gosh, you are terrible. You know that. Doing training with her earlier, and she found the treats sitting over there. All right. And so we then return the type right there, so as part of the use deep memo. That's that. I was going to then also go through a real quick example of here we'll go ahead of a memoed component in action. So we'll replace the screen, and there we go. And I'll stay sharing. Components. Here we go. Okay. So here we are. We should be over here now. And actually, I didn't even realize that had it, but that's good. This actually uses the use deep memo as well. So this is BSoft Components radio button component, the current version of it, at least. We're currently in the process of actually modifying this and changing it to a headless component. But currently, we do have the old version of the component here. It's pretty basic. I mean, it's just a radio button, so it's just a list of items, things like that. But as you can see, this is what I'm talking about when you memo a component. So when you memo a component, basically you end up with this now has memoized the component, and now if you actually, this will only render if any of these change. Now in our case here, let's see here, data is possible. It is possible that data could have, yeah, there we go, because it's JSON data, so it could be an object. So it is possible that you could have actual data passed in to make it a radio button component. If you're going to do such a thing, if you're going to use this component, the best thing to do, because text field, value field, these are all strings. Value, let's see what value is here. Value is a string because it's the actual value property. So in a radio button, only one could be selected. So the value is, it's you have the text and you have the value. So this is the value that you want to be selected. So it's a default selection type situation. Here's the label, which is a little label, blah, blah, blah. I think you can kind of understand this. Location, orientation, just how it's laid out. Technically, these are numbers. They're enumerations in TypeScript, but they're numbers is all they are. So it shouldn't have a problem with those. Class name is string. Use animation as Boolean. OnChange is a function. OnChange will have the same potential problems. So once again, if you're using a component like this, you should probably either use memo, or in the case of functions, you can use callback on a function that's passed to something like this, because you don't want this being re-rendered each time around. It's rare that your OnChange would need to change too often. It's more than likely it's going to be a pretty standard thing. So yeah, you'd probably want to do that, and the data you pass in, you'd probably want to memo those as well. Here's use deep memo as an actual usage here. So basically, the usage of the data, which is basically JSON data, it is passed as a dependency. So each time this thing is rendered, it comes into here and it determines if it actually has changed. Has any of the properties in that data changed? If so, then once again, we go ahead and pull out the static data here. And yeah, that's pretty much it. We basically just pass it to the render items. Render items then goes through and actually renders the radio button, which then ends up being a radio item. So pretty basic. This thing is pretty simple overall, but the idea is there. This is how rendering actually works. So when you're coming through, you're sitting there and you're trying to determine, React is trying to determine, have any of these properties changed? Like I said, if you don't memo the data that's being passed to the actual component itself, then each time through, this will re-render over and over again and kind of defeat the purpose of the memo. But if you do, then this thing will be much faster. It won't render nearly as often. It really shouldn't, unless there's some kind of change anyways. It's a good, like I said, it's a good concept it's a good idea to try and decrease the number of renders. And that's really where React rendering comes in. I guess we can talk about one more thing. So this is the code part of this, but I do want to talk about one more thing here about this. Let's go ahead and we'll stop the screen sharing. All right. There's one more part of this. So you've got the whole, that was the memo concept. That was part of React rendering, but there's one more thing about React rendering as well that needs to take place here. That one more thing, is the virtual DOM. That's the next part of React rendering. So that's where React rendering plays a part, though. React rendering plays a part with this whole concept of virtual DOM. Virtual DOM is basically, instead of React actually modifying the DOM directly, in other words, it actually accessing and directly modifying the DOM and changing the DOM right there, what it does is it keeps, for lack of a better word, it keeps a list, basically. Part of React rendering is that it goes through and, once again, based upon properties and components, and if a component is memoed and all of those kinds of things, it goes through and there's a couple different parts to React rendering. The first part is it has to determine which components need to render. Then what it does is it actually runs the render of that component. So even if your component isn't memoed and it does get run, if nothing changes, nothing gets updated. That's pretty much how React rendering works. So if you don't memo your components, especially if components are simple, sometimes it's not really worth memoing, especially if they're not going to be something that's going to be hit a lot and is intensive. Maybe it's best not to memo. Maybe it's just best not to memo at all. But if there's a lot of stuff going on each time when your component renders, it's good to kind of have the consideration and think about whether or not you need to actually memo your component and then think down that path. Because what will happen is, basically, if your component is small and it's a very simple, maybe just something that's a little tag up in a corner or something like that, something, just some little visual thing, and all there is a couple of strings passed into it, that's not going to take that much to render. And once again, what'll happen is React will create JSX. And so it will take the previously stored JSX for that component and take the newly created JSX after the render and compare them. If those items are the same, it doesn't get added into the commit phase of React rendering. So that's what happens. React runs through every component that is supposed to runs. Basically, it goes through and it makes its render. Each component returns that render as to what the output would be, what the new output of that component would be. And React then does a comparison against the previous render of that same component. If those things are different, then it gets added to the commit phase and actually gets put into the commit list of DOM items to be updated. And so it batches them at the very end and then goes through and does a mass update. That's why you hear people talk about how React is more performant. That's why you hear those things. Now, just like anything else, I think it's funny when people say React is anything is more performant, because someone who really doesn't do a very good job of writing their React application could make React slow. So just because React does this doesn't necessarily mean that using it by default makes it faster, depending upon if the person who's writing it knows what they're doing. So someone who's writing Angular, and I've heard Angular is now popular again. I don't know why. I haven't looked into it enough. I've been in React world for a little time now. I do want to jump back over. I did do Angular before. Previously, I did Angular for about, but the last project I was on was 3.5 years ago. So I was doing Angular there, and I never had a problem with it. But but as an example, if you have a really good team of developers who really know how to work in front end technologies, you could have an Angular application, and let's not talk about current state. But even a number of years ago, you could have an Angular application that could run faster than a React application, simply because the people who wrote the Angular application know how to use the technologies better than the people who wrote the React applications. Trust me, I've seen some React applications that are slow as can be. They're slow as can be because they're just constantly rendering, and they're just render because people aren't. I don't know if it's just because they have this mindset where they believe that React is fast, so therefore instantly they can do whatever they want to, or what that is. But the shadow DOM and the whole concept of it, and what I just discussed there just a minute ago, is why people say that. They say that because it doesn't modify the DOM directly. It only modifies the pieces of the DOM that need to be updated. Now, there are some side effects from this, because this is yet another question I asked. Like I said, the reason I decided to bring this up is because I do interviews for my job a lot. I'm kind of one of the senior front end devs at the job. Matter of fact, I think I am the senior front end dev at the job. By the way, that's the company that I work for. His name's Myosh. OSH stands for Occupational Safety and Health. Now, our software isn't specific to the occupational safety and health. We do have clients that use it for things. Basically, what the application does is it allows people to create their own forms, input their own data. It goes a lot further than just forms and data, though. We've got to the point where they can actually, dependent upon the answers in certain fields, we can have other fields, sections, whatever of the form become not just visible, but become required. So if they don't answer something a certain way, that part isn't required. If they do answer it this way, then this section opens up and these fields now become required. And it's really quite complex what it does. And like I said, we aren't just for occupational safety and health, but that type of a situation plays very well to to that industry, because there's a lot of times where people come on sites and they need to fill out certain, they need to identify that they have been told certain security requirements, certain things that they have to do while they're on site to keep themselves safe, and that someone has checked them out and all that kind of stuff. So our software lends very well to that industry, and that's where most of our clients are. But we do have other clients who are not that, who do need to actually who want to be able to create their own forms, have their forms validated, make sure that no matter what the answers of the users are, that they can actually make sure that those forms are filled in correctly, and all that kind of stuff. And these aren't just simple "are they required" type field stuff. Some of these things are quite complex, and can have some very complex logic in them. Um, so, that's why this is one of the reasons we went down the React route, is because it's very flexible and all that kind of stuff. So as part of that, that's where I was headed to. As part of that, I do interviews with people, and we've recently been trying to bring in more senior level people. So I've been asking more questions about React rendering lately. So that's where the whole topic came up when I was asked earlier what the next topic was. I said, well, why not talk about that? I've and you'd be surprised how many even senior level people don't really know how React rendering works under the hood. Um, and all the how intricate it is, and how many different things are at play here, and how it works, and how these comparisons happen, and how React is supposed to be faster because of the shadow DOM, and how the shadow DOM works, and what comes into play with React rendering, how React rendering plays this, how it determines when a component gets rendered, and how memoing works, and all of those kinds of things, because all of these things play in React rendering. So all of these are very important parts of React rendering. So that's where the concept came from. That's why I decided to talk about it, because I think it's a pretty important concept. I think it's a good thing for people to know. I think it's a good thing for people who are even more senior level developers to potentially watch and potentially know, because it is, once you learn about it, it is a very good thing to know, and it's a very good resource. There are articles out there about React rendering. Just look it up, React rendering. I actually ended up losing a couple of them. I was gonna showcase. I had a series of articles. I think there were 3 different articles about React rendering, which were really great. But like I said, I recently upgraded to a new Mac, and I thought that Firefox would keep. I had Sync on, and I thought it would keep those, and maybe it still hasn't. Maybe I just haven't figured out how to get it back. But luckily, I still had a lot of them in Chrome, so I didn't lose too many, but I did end up losing those particular articles, because those are some really good articles. But just search it out there; it's not hard to find React rendering. There's a good series of articles. I could dig through our team stuff and find it. But man, that article was years ago. That was a couple of years back. I don't know how easy it's going to be to find. I do think Teams has searchability, but were we always on Teams? Trying to remember when we went to Teams. I think we were at the time. Anyways, yeah. So as always, you can ask me questions. You can hit me up about anything. You know, I'm here on X. I'm here on LinkedIn, YouTube, Twitch. You name it. You can ask me on any of those platforms. You can just direct connect to me. You can follow. You can message. Any questions you have about any of this type of stuff, you can always ask. Yeah, I think I'm going to go ahead and finish up for now, but I appreciate everyone who showed up live. Looked like we had a good number of people. Brandon, I want to thank you for your question there. That was a very good question, and helped me dig in a little bit more as to why I'm talking about this. To his point, most of my ideas for my live streams come from things that happen to me in daily life, things that I deal with all the time. So it's definitely that's usually why I make the choices of the items I do, of the things I decide to talk about, because like with this one, this is something I've interviewed on, I think 3 different times within the last couple of weeks, and I've been pretty surprised how little people actually know. So I think it's a good thing for it to be out there for people to learn about these kinds of things and how these things work, because it's going to help people create better applications, more performant applications, and just overall, a better web. So you're very welcome there. So that's it for me. Like I said, hit me up if you have any questions. But we will see you guys next week, and I'll if you have any ideas for the next stream, definitely throw it out there. I know I had one just